I would like to talk today about smaller and better space technology for science and business, and overall give you an overview of the motivation, why we are doing space technology, why we are doing it at Aalto University, and what this space technology even is. And we will start from a pretty far and pretty global. So our world is a spaceship. Our world is a planet going through the empty space. It's powered by the nearest star, and it contains everything we know is living, is life, and in most cases contains also everything which we dare and love in our life. All this complexity, beauty, everything is stored or happens on the thin surface layer of the planet, which is only few tens of kilometers thick. We, as a species, as the only biological species, have been able to wonder this beauty from the vantage point far beyond the Earth's surface, which is space. So we are the only species who can go to space and take a look on this planet, on this beauty, on this system. And for many decades, we have been launching satellites which are able to take a look from this vantage point to the whole world, to the whole planet, to the whole ecosystem, to the whole social system, and let's say even like a transportation system of this planet. And what we see is the changing world. We see how much human expansion in the nature is changing the face of our planet, what is changing, what is moving. And we also are able to see the areas which we cannot see with the normal eyes or with the normal optical cameras from space, for example, radars. Radars extremely important, especially for the northern areas. If you think about our polar caps, then they have half of the year they have night. And most of the important processes related to climate change are actually taking place in these very, very sensitive areas. In order to emphasize how important are the satellites and also radars included, let's take a look on the satellite measurements made and compiled by European Space Agency on the extent of the ice cap on the North Pole area. Here you can see how this extent of the ice cap has been changed between the years 2010 and 1978. 1978. Why 1978? Because 1978, the first radar satellite ever was launched. Before this time, we didn't have much idea or much knowledge or information about the extent of the ice cap. We just didn't know because in the northern areas there are nobody. So satellites are important tool to even know about climate change. Tens and hundreds of satellites are measuring Earth's surface with the different wavelengths, with the different technologies, trying to make a comprehensive image of the whole Earth system in order to understand it, in order to maintain it, in order to manage it. Like we took the control over the fields when we started with our agriculture, we have to take the control over the atmosphere, over the oceans, over the whole Earth system, and we can only do it by having an up-to-date information about what is going on. So one satellite is an excellent tool to gathering information about the Earth. But as you can see on this movie, it's not very quick way. In order to have enough information for fast-changing world and even going to the timescales which are related to human economy, we need to have much more satellites. we need to have hundreds and thousands of satellites in order to cover the vast field of the Earth's surface. How to do it with this kind of satellites? This is one of the satellites which was launched 2002, I remember right, which is Envisat. The satellite weighs 8 tons and it cost almost 3 billion euros to develop. This is one of the satellites which was measuring the very polar gap area and was instrumental of getting all this information available for us. But these are very big and very expensive satellites. How we are having a possibility to even like put 2 of those into the orbit. So can we miniaturize somehow these satellites into the smaller platforms in order to afford to have more eyes in the sky to see what is actually happening? Can we shrink it to the size of the shoebox? At least we tried. So in 2010, the first nanosatellite team started at Aalto University, and it was a student-led project financed by Aalto University, and we tried to build a small satellite which is much smaller and very much cheaper than this big Envisat type of environmental satellite, in order to make satellites more affordable, more useful, and more frequent. So we started with a small team of only 6 students, which started to grow very fast. And this is the team approximately 2011. And it took many years to us to figure out how to even build a satellite, because there was no satellites built before in Finland, not talking about even Aalto University. So the enthusiasm and the courage and drive of the young generation was keeping this project going for several years. And finally, 2016, we had our satellite ready, and it was a small shoebox-sized satellite, which we hoped is able to contribute even something to the future technology. So this was the first satellite which is also taken into the register of Finnish space objects, although we actually launched an Aalto-2 satellite a couple of months before, but it went to the Netherlands space register because it was a part of a big satellite constellation for science. So 2017, after changing a couple of times the rocket and the ride to space, we were able to, in the mid-summer eve, launch the satellite to space and finally having our first instrument in space developed mostly by students, and having instruments from different professional high-grade institutions in Finland, like VTT, Finnish Meteorological Institute, and University of Turku, who provided the scientific instruments to this satellite. So the satellite, luckily, worked, even though we were amateurs and just beginners building a satellite. And in a few weeks, we started to download data from the satellite, and we found out what was working, what was not working. We got the first satellite image from Finnish satellite. We got the first spectrometer image from a Finnish satellite, and made the first radiation maps on low Earth orbit with a Finnish satellite. Took some more pictures and calibrated the instruments and attitude systems and GNSS systems and so on. And it was a great success. The satellite is still there, going to deorbit probably this year, somewhere in the autumn, when it comes down so close to the atmosphere that it will bump into the atmosphere and burn like a star or a meteorite in atmosphere, and nothing is left of this satellite. But much more important than this satellite and the first satellite of Finland was the crowd, the people, the students who were grown with the idea and dream that they can build satellites themselves. So this generation of new people started up wonderful things in Finland. ISAI, Kuvaspace, Arctic Astronautics, Aurora Propulsion, started companies which were developing, say, space technology in Finland and taking the whole space scene and space industry into entirely new heights. For example, ISAI is one of the world-leading companies around the big billboards of the big cities on our planet. And they developed a very small radar satellite, which is able, not from the shoebox size, but let's say it's more like a refrigerator size, under 100 kilos to deliver radar images and even radar videos from space. So providing very similar service as it was provided by the 8-ton Envisat with the ASAR instrument. They have been also providing this video product, which is totally new and novel in the entire world. The second company, Kuvaspace, has been already launching 3 satellites as well, and they are working at the moment on a constellation of small shoebox-sized satellites which are taking hyperspectral images from space anywhere we want to have, and they are developing more than 100 satellites into the constellation. These satellites are much, much, much smaller than Envisat was, and ISAI and Kuvaspace constellations are very soon or already now able to provide very similar or even much better and definitely much more frequently updated data products, which were delivered also by ASAR Envisat. And this is the great addition for the fleet in space, which tries to solve the sustainability problems and information. However, the space has its own sustainability problems. When we are launching more and more satellites, the space is getting crowded and we have more and more space debris in space. Therefore, we as a university are keeping working on the space platforms and small satellites in order to understand the radiation environment, to make these small satellites more tolerable for the space radiation, and working out a reasonable deorbiting concepts which could do and bring these satellites down from space. We are combining the best knowledge from the best universities who are doing space science in Finland, Helsinki University, University of Turku, Aalto-University, and Finnish Meteorological Institute to build instruments for space science, deorbiting tests, radiation tolerance tests. And we are not only building these systems, we are also developing the methods how to test these space systems, because the space is a very hostile environment for humans and for the technology. And in order to make sure that a small satellite can actually survive for the lifetime of its mission in space, we need to make a lot of rigorous testing. And in order to make it cost efficiently, we have to develop new and novel methods. Our group at Aalto University is one of the few groups in the world who can develop in the university with students entire satellite platform, which includes all the electronics and all the sensors which are there. We are having a very tight collaboration with many institutes in Finland and abroad in order to take new satellites to space. At the moment, we are using rockets from United States, but already in a few years, it might be that we are launching our satellites from Kiruna and Andoya from Sweden and Norway. So we are keeping working with space technology in different projects for navigation, space science, remote sensing, and other topics. And I would like to conclude my talk with a statement that sustainable future requires better and smarter space technology to take the pulse of our planet for sustainable development on Earth. We build the space for the future. Thank you very much.